We are looking at question number 16 from chapter 25 of C Verma. The question says a ball is dropped on a floor from a height of 2 meter. After the collision, it rises up to a height of 1.5 meter. Assume that 40% of the mechanical energy lost goes as thermal energy into the ball. Calculate the rise in the temperature of the ball in the collision. Heat capacity of the ball is given. Now in this question there's one tiny mistake. The mass of the ball is not given, but we will be needing it. So let's say the mass of the ball is 1 kg. If you take 1 kg as the mass of the ball, you will be able to get the answer. Okay. Now, so let's say this is your ground and this is the initial position of the ball. So the initial position of the ball is given to be 2 meter. Okay. And after bouncing with the ground, the ball rises up to a height lesser than the original, and the new height is given to be how much? 1.5 meter. Okay. So initially the ball has some potential energy ui, and ui will be how much? Mass into g into initial height. So mass is given 1, g is let's say 10, and initial height is 2. So this will be 20 joules is the initial potential energy. Final potential energy will be again mgh. So mass is 1, g is 10 into height is 1.5. So this will be equal to 15 joules. Now potential energy is also mechanical energy, right? So here the loss in mechanical energy is how much? Loss in mechanical energy will be 20 minus 15. So that is 5 joules. Okay. Now the question says that 40% of the mechanical energy lost goes as thermal energy. So the thermal energy will be what? That will be 40% of mechanical energy lost, 5 joules. Okay, so this will be 40 by 100 into 5. Okay. So this will be equal to 2 joules. So the thermal energy is 2 joules, which is gained by the ball. So the ball will gain 2 joules of energy. So first of all, heat is equal to heat capacity. So let's say heat capacity is capital H into change in temperature. So heat supplied is how much? 2 joules. And heat capacity is given in the question to be 800 joule per Kelvin. So into 800 into delta T. So when you solve this, you will obtain delta T is equal to 0.0025 degrees Celsius. Okay, or that will be equal to 2.5 into 10 power minus 3 degrees Celsius. That will be your answer.